Welcome to a lesson on inverse variation. The goals of this video are to define inverse variation and also to solve inverse variation problems. But let's start by taking a look at some real-life examples of inverse variation. Our first example, the time that a trip takes and the speed traveled would be an example of inverse variation. So this is assuming the distance of the trip would be fixed. So let's say the distance of the trip is 250 miles. Then the time of the trip t would be equal to 250 miles divided by the rate in miles per hour, which we'll call r. So if our rate is 50 miles per hour, it would take 5 hours, versus if it was 25 miles per hour, it would take twice that time, or 10 hours. The next example, the time it takes to spread landscaping rock and the number of people working. So for example, if it's determined that the job is going to take 12 hours, the total time t to complete the job would be 12 hours divided by n, which is the number of workers. So if we have one worker, it would take 12 hours, 2 workers, it would take 6 hours, 3 workers, 4 hours, and so on. This is an example of inverse variation. And then lastly, the amount of money needed per person for gasoline and the number of people in the car. So for example, if we know that it's going to cost $45 worth of gas to go on a trip, the cost per person, C, would be equal to $45 divided by the number of people in the car. So notice that as n increases, the total cost would decrease. This is an example of inverse variation. More formally, these all represent inverse variation. Y varies indirectly as x. Y is inversely proportional to x. The equation y equals k divided by x for some constant k, as well as x times y is equal to k for some constant k. Looking at these two equations here, if we were to put y over 1 and then cross multiply, we would get this second equation here. X times y must equal 1 times k, or k. And the number k is called the constant of proportionality. We can also say, as the absolute value of one quantity gets bigger, the absolute value of another quantity gets smaller, such that the product is always the same. If this is the case, this would be inverse variation. Let's take a quick look at the graph of y equals k over x. The blue graph is the graph of y equals 2 divided by x, and the red graph is the graph of y equals negative 2 divided by x. And again, in many cases, we're only concerned about the first quadrant, and what you'll notice is, as x increases, y would decrease. Let's take a look at our examples. Here we're told that y varies inversely as x, which means we'll be using the equation y equals k divided by x. Then we're told that y equals 4 when x equals 2. We want to determine the inverse variation equation and then determine y when x equals 16. So we first need to determine the value of k, our constant, and we can do that using y equals 4 when x equals 2. So by performing substitution, we'll have 4 is equal to k divided by 2. We can put this over 1 and cross multiply. So we have k times 1, or k, is equal to 4 times 2, which is 8. So our inverse variation equation will be y equals 8 divided by x. And now we can answer the second part of the question, determine y when x equals 16. So we'd have y equals 8 divided by 16. This simplifies to 1/2. So when x is equal to 16, y is equal to 1/2. On this example, the time t required to empty a tank varies inversely as the rate r of pumping. So from that first sentence, we know that t varies inversely as r. That means our equation is going to be t equals some constant k divided by our rate r. The next sentence states that if a pump can empty a tank in 2.5 hours at a rate of 400 gallons per minute, how long will it take to empty a tank at 500 gallons per minute? So using a time of 2.5 hours and a rate of 400 gallons per minute, we can determine the value of k. However, one thing about this, notice that the time is in hours and the rate is in gallons per minute. Even though it's not necessary here, it's usually important to have common units. So I'm going to go ahead and convert 2.5 hours into minutes. And since there's 60 minutes per hour, this is going to be 150 minutes for time. So we have 150 is going to equal k divided by our rate of 400 gallons per minute. Now if we cross multiply, we'll have k equals 60,000. Now we do have to remember though that our time will be in minutes when we finish. So our inverse variation equation will be time equals 60,000 divided by the rate in gallons per minute. So now if the rate changes to 500 gallons per minute, we'll have time equals 60,000 divided by 500. This will give us t, or time, equals 120 minutes, which we could convert to 2 hours. So when the rate increases to 500 gallons per minute, the total time would be 120 minutes or 2 hours. So if the rate increases, notice our total time has decreased. Let's take a look at another example. Here we're given the force needed to break a board varies inversely with the length of the board. So F varies inversely with L. So we have F equals K divided by L. If it takes 24 pounds of pressure to break a board 2 feet long, how many pounds of pressure will it take to break a board that is 5 feet long? Again, using 24 and 2, we can determine the value of K. So when the force is 24 pounds, we know a board of length 2 feet will break. Now we can cross multiply, so we have K equals 24 times 2, it's 48. So our inverse variation equation will be the force is equal to 48 divided by the length. So now if the length increases to 5 feet, it's going to take less force to break. The force will be equal to 48 divided by 5. So we'll only take 9.6 pounds of pressure to break that board. And I think we have time for one more example. Sometimes our inverse variation equation will change slightly. Here it says that y varies inversely as the square root of x. So we're going to have y equals k divided by not just x, but the square root of x. And then from here it's going to be pretty much the same. We're told y equals 6 when x is 16. That'll allow us to determine k. Let's go ahead and do that. When y is 6, x is 16. So we have the square root of 16. So we have 6 over 1 equals k over 4. Cross multiply. K equals 24. So our equation for this problem will be y equals 24 divided by the square root of x. So this is our inverse variation equation. And then lastly, we want to determine y when x equals 4. So again, we'll just perform substitution. Y equals 24 divided by the square root of 4. That's 2. 24 divided by 2 is 12. So when x is 4, y would be 12. And that's going to have to do it for this video. I hope you found it helpful.